Welcome, everyone, to the Good Tidings, the channel dedicated to helping you unlock your full potential every single day. We are so glad you're here.
That's right, Sarah, and a massive welcome to our incredible community. You are the reason we do this, and your energy fuels every single episode. We truly value having you with us on this journey.
Absolutely. We believe every day is a chance to learn, grow, and make a positive impact. So if you're ready for some sustainable, ethical, and practical insights, do us a quick favor and hit that subscribe button right now so you never miss out.
Today, we're diving into a topic that has moved from theoretical discussions right into the very architecture of our modern world, artificial intelligence. And as it becomes more powerful, we have to ask a question that's more urgent by the day. Is it fair?
That is the essential question, Alex. It's so critical because AI systems are no longer just in the background recommending movies. They are now front and center, helping to decide who gets a home loan, who is considered for a crucial job interview, or even who gets access to specialized healthcare.
Exactly. And a powerful body of evidence now shows that when these systems make mistakes, and they all make mistakes, the harm is not distributed randomly. It consistently concentrates in specific, often already disadvantaged communities.
This is why experts frame this as not a simple coding bug, but as a deep socio-technical problem. To really get it, the U.S. National Institute of Standards and Technology, or NIST, identifies three key faces of bias. Let's start with the first one, systemic bias.
I think of systemic bias as the ghost of society's past haunting the machine. It's the accumulated bias that already exists in our institutions, our historical practices, and our societal norms, which then becomes the very data we use to train an AI.
Precisely. Imagine an algorithm designed to screen applicants for a top executive role. If you train it on 50 years of a company's hiring data, and that company for decades overwhelmingly promoted men, the AI will learn that pattern as the correct one. It has no context for the glass ceiling. It only knows the data it's given.
It becomes a perfect, uncritical echo of our own biased history. It's like trying to draw pure water from a polluted well. That brings us to the second face of bias, which is more directly tied to the data and the modeling process itself.
There's no better illustration of this than the landmark gender shade study from MIT. It was a real wake-up call. Researchers tested major facial analysis systems and found they had error rates as high as 34.7% for darker-skinned women.
34%. That's staggering. It's essentially non-functional for that group. Meanwhile, for lighter-skinned men, the error rate was less than 1%. And it's crucial to understand the system wasn't programmed with malice. The engineers didn't tell it to fail. It was simply starved of diverse data.
And that leads to the third phase, which is perhaps the most insidious, human cognitive bias. This brings the focus right back to the people who are building, managing, and using these systems. It's about our own mental shortcuts and blind spots.
This could be the team of data labelers whose own unconscious biases influence how they classify information. But perhaps more dangerously, it's the manager or the loan officer who exhibits what researchers call automation complacency. They just blindly trust the machine's output, abdicating their own professional responsibility and critical judgment.
So these three forces, the systemic, the statistical, and the human bias, they create this powerful feedback loop where each one amplifies the others. This complexity leads to what might be the most challenging part of this entire discussion. What does fairness even mean in this context?
That's right. It turns out many of our intuitive definitions of fairness are often mathematically at odds. For example, one idea is that a model's predictions should be equally accurate for all demographic groups. We can call that equalized odds.
That makes sense. You want the same error rate for everyone. But here's another equally valid idea, that a risk score, say a 7 out of 10 for a loan, should represent the exact same level of actual risk regardless of who you are. That's called calibration. But here's the bombshell. A foundational discovery in this field proved that in almost any real-world setting, you cannot satisfy both of those definitions of fairness at the same time. You're forced to choose.
And that choice has profound real-world consequences. We saw this with ProPublica's groundbreaking investigation of the COMPAS tool, which was used to predict recidivism. The tool was almost twice as likely to wrongly label Black defendants who would not reoffend as being high risk, a false positive with devastating consequences for that individual.
Exactly. And at the same time, it was more likely to wrongly label white defendants who would go on to reoffend as low risk. The overall accuracy number the company promoted looked moderate, but it completely hid a deeply disturbing disparity in the type of errors being made and who was forced to bear the cost.
These cases have thankfully pushed this conversation from academic circles into boardrooms and government halls. There's now a clear understanding that this requires robust governance from the top down.
And we're finally seeing real structural progress. The NIST AI Risk Management Framework reframes bias as a core operational risk. The EU's AI Act is creating legally binding requirements for transparency and human oversight for high-risk systems.
So we have these big top-down regulations, but that can feel a bit abstract. What about for the teams on the ground, the people actually building this stuff? What are the practical solutions emerging there?
That's a great question, Alex, because that's where the real change happens. One of the biggest shifts is the move towards truly interdisciplinary teams. It's no longer enough to have a room full of brilliant software engineers. Leading organizations are now bringing sociologists, ethicists, and legal experts into the development process from day one.
So you have people whose entire job is to think about the societal impact, not just the code. I love that. It's like having a conscience built directly into the team.
Exactly. And another powerful technique that's becoming standard is called red teaming. This is where you have a dedicated team whose job is to try and break the AI. They actively search and exploit its biases. They might create synthetic data of underrepresented groups or feed it ambiguous scenarios to see how it responds under pressure. It's a form of ethical hacking to find flaws before they cause real-world harm.
It's like a stress test for fairness. Instead of just hoping the model works for everyone, you're actively trying to find the people it doesn't work for. That feels so much more proactive and responsible.
It is, and this all ties into the rise of tools that we like to call nutrition labels for AI. They're officially called data sheets and model cards. They document where the data came from, its known limitations, and most importantly, exactly how the model performs for different subgroups, for men and women, for different racial and ethnic groups, and their intersections.
It's a powerful shift towards radical operational transparency. So when you put it all together, the path forward seems to be this combination of meticulous data governance, these new proactive techniques like red teaming, thoughtful model development that acknowledges the fairness trade-offs, and a durable framework of human-in-the-loop oversight.
That's it. It's not about finding that one magical, unbiased algorithm. Fairness isn't a feature you can add or a patch you can apply at the end. It has to be a foundational principle, a continuous, disciplined practice that is integrated across the entire life cycle of the system.
And that brings us to our question for you, our amazing community. When an AI system has to make a trade-off between different competing types of fairness, for example, being wrong in the same way for all groups versus ensuring its risk scores mean the same thing for all groups, who should be responsible for deciding which value to prioritize? Is it the engineers who build the system? Should it be a company's internal ethics board? Should government regulators make the call? Or does the public need a seat at that table?
We really want to hear from you. What do you think? Drop us a comment below and let's get this important conversation